Divisibility test. Quick tricks or divisibility test that we can use to determine if a number can be divided by a smaller number. So we have a couple different divisibility tests. So 2. It can be divided by 2 when the last digit is even. This is when the number ends in a 0, a 2, 4, 6, or an 8. 3. It can be divided by 3 when the sum of the digits is divisible by 3. So for example, we have 21. 2 plus 1 is 3, which that can be divided by 3 because 2 plus 1 is 3. Divided by 3 is just equal to 1, so there's no remainder. Now let's look at 5. It could be divided by 5 when the last digit is a 0 or 5. And then for the numbers 7, 11, 13, 17, 19, we're going to use long division. So let's look at example 1. Example 1. A support plate is 12 inches long. 12 is divisible by which prime numbers? So we're going to go over our divisibility test. 2. Is it divisible by 2? Therefore, is it even? And the answer is yes, because it ends in a 2, so we know it's even. So we would say yes, as it is even. Next, we can look at 3. Is this divisible by 3? And so we can add 1 plus 2, which is 3, and 3 is divisible by 3. So we would say yes, as the sum is divisible by 3. And the sum of the digits, that is. Then we can look at 5. This is no, as does not end with a 0 or a 5. 7, it can't be done. 11, it can't be done. So we see that the prime numbers that it is divisible by is 2 and 3. And also 1 and 12, of course, because so we have 1, 2, 3, and 12 are the prime numbers. Now let's look at another example. Example 2. There is 2,730 pounds of steel. 2,730 is divisible by which prime numbers? So the first thing we're going to do is look to see if this is even. And we're just going to go ahead and see that it is because it ends in a 0. So we would say yes, as it is even. Then when we get to these large numbers, what's easy to do is to start dividing by these prime numbers. So since it's divisible by 2, we'll put 2 out here. Now 2 can go to 2 one time. We go ahead and subtract. 2 times 1 is 2. So we get 0. We're going to go ahead and bring down the 7. 2 can go into 7 now 3 times, because 2 times 3 is 6. We go ahead and subtract. 7 minus 6 is 1. Then we're going to go ahead and bring down this 3. 2 can go into 13 6 times. 2 times 6 is 12. We subtract. 13 minus 12 is 1. Bring down the 0. 2 can go into 10 5 times. Because 2 times 5 is 10. We subtract, we get 0. So the next thing, as we go down our divisibility test, we can look at 3. So our trick is to see what the sum is and see if it's divisible by 3. So 1 plus 3 is 4, plus 6 is 10, plus 5 is 15. And 15 is divisible by 3 because that's 5. So we can go ahead and just rewrite this number and divide it by 3. 3 can go to 13 4 times because 3 times 4 is 12. We subtract. 13 minus 12 is 1. Then we're going to go ahead and bring down the 6. 3 can go to 16 5 times. 3 times 5 is 15, we subtract 16 minus 15, we get 1. We'll bring down that 5. Then we go 3 can go to 15 5 times. So 3 times 5 is 15. So we go ahead and subtract that. 15 minus 15 is 0. So we say yes, as the sum is divisible by 3. And we also confirmed when we divided it by 3, we got a number that was whole. So the next thing would be to take 455 and look at the next test, which would be 5. And we see that it ends in a 5. So we know it can be divided by 5. So let's go ahead and do this. So 5 can go to 45 9 times. 5 times 9 is 45. We're going to go ahead and subtract. 45 minus 45 is 0. Bring down this 5. Now 5 can go to 5 one time, because 5 times 1 is 5. We subtract, we get 0. So we would say yes. Now, these are all, the box ones are the prime numbers. Now we look at 91. And the next thing we do is we're going to see with 7 if it can be divided by 7. So we put 7 on here. And we start to use long division. So 7 can go into 9 one time. So 7 times 1 is 7. We go ahead and subtract. We get 2. Then we're going to go ahead and bring down this 1, because 7 can go into 21 then 3 times. 7 times 3 is 21. We subtract and we get 0. Notice that we have a 7 and a 13. So we would say yes here. Now, 13, as we get this new number, cannot be divided further down, as that's a prime number. So we would say the prime numbers are these. Example 3. 363 is divisible by which prime numbers? So we have 363. So we notice that it ends in a 3. So we would say, no, it's not divisible by 2 because it's not even. Now 3. So we take 363. So 3 plus 6 is 9, plus 3 is 12, which can be divided by 3 because that's 4. So we would say yes. So let's actually divide this by 3. 3 can go to 3 one times. 3 times 1 is 3. We subtract, we get 0. Then we get, bring down the 6. 3 can go to 6 2 times. 3 times 2 is 6. We go ahead and subtract. 6 minus 6 is 0. Then we're going to go ahead and bring down this 3. 3 can go to 3 one time. So we subtract, we get 0 here. So now we're left with 121. So the next question would be, is 121 divisible, or can it be divided by 5? And the answer is no, because it doesn't end in a 0 or a 5. So we would then say no. Does not end in a 0 or 5. Then we look at 7. So the next thing would be is just long division with this. So 7 can go into 12 one times, because 7 times 1 is 7. We go ahead and subtract. 12 minus 7 is 5. We're going to go ahead and bring down this 1. Now 7 cannot go into 51 evenly. So this is a no. Next is 121, and we're going to go ahead and divide it by 11. So 11 can go to 12 one time. 11 times 1 is 11. We subtract, we get 1 here. We're going to go ahead and bring down this other 1, so now we have 11. 11 can go into 11 one time. 11 times 1 is 11. We subtract, we get 0. So we would say 11 is yes. And since we end with 11, then we know that it cannot be divisible by any other prime numbers we have not explored or anything, because we have arrived.